It says, remember that we previously learned that solutions to quadratics have more than one name. Zeros, roots, x-intercepts, these are all the same thing. They're synonyms for solutions. You have to know all those words because the EOC might say, what are the zeros? And the ACT, as juniors and seniors, it might say, what are the x-intercepts? On a snapshot, I might say, what are the roots? It all means the exact same thing. You're trying to find the x-intercepts of the graph, okay? So on number 5, it says solve by factoring. So we can't do SADMAP here because there's this pesky x in the way. So I could add 1 over, but that doesn't do me any good because I can't square root x squared if there's another x blocking me from doing that. So we're going to follow these steps. The first step, it says set the polynomial expression equal to 0. Kind of like we did last class, because remember to graph it, it has to be equal to 0. So what do I need to do to get this so it's equal to 0?
Put that 2 on the other side.
Subtract 2 over to the constant. So now I have 0 equals 2x squared plus x, and negative 1 minus 2 is negative 3. So if I can't get x by itself, we need to find a way to separate the x's. The way that we separate x's is by factoring. So now we're going to factor the polynomial. So how do I factor something with 1, 2, 3 terms?
Bottoms that boy up.
Bottoms that boy up. So we're going to go A times C. So this is a good factoring review. We're going to be factoring until May. Every single test for this whole semester you're going to have to factor. So this is a good review. What is 2 times negative 3? Negative 6. That means one's positive and one's negative, right? If we're multiplying to be a negative number, one's positive and one's negative. So what factors of negative 6 add up to the b value in the middle, which is 1x?
Positive 3, negative 2.
Does that work?
Yeah.
3 minus 2, is that 1?
Yeah.
Yeah. So what we do is we draw our two factors. So one of them we just figured out is x plus 3. The other one is x minus 2. But we're not done with bottoms up yet because we don't have any bottoms. We got to get some bottoms. So what do I do next?
Divide by
We divide those numbers by a, which in this case is 2. And then what do we do if 3 over 2 doesn't reduce? The 2 goes to the front. That's how it gets the name bottoms up. So that becomes 2x plus 3. And then on my other factor, I have 2 divided by 2. So that just becomes x minus 1. You remember that? We did that in geometry last year too. So we should be getting pretty good at bottoms up by now. Okay, now it says the next step, set each factor equal to 0 and solve. We did this last semester on Desmos. Remember, if the factor is x minus 1, where is it crossing the x-axis at?
X
Plus 1. The reason that is because if you set the factor x minus 1 equal to 0, because I'm trying to find out where does the polynomial equal 0. That's the x-axis, right? If you solve for x, we add 1 over, and what does x equal? Positive 1. It's opposite, because we're setting x equal to 0. So that's one of my answers. Now this one's not quite as obvious. It's not just going to be the opposite, because this one here, there's a 2 in front. But it's no different. All we do is we just set that factor, which is 2x plus 3, equal to 0, and we figure out where that x value is at on the x-axis. So subtract 3 over. That gives me 2x equals negative 3. And then we do what? Divide by 2. So my answer is negative 3/2, or negative 1.5. So those are my two values of x when we're on the x-axis, when this quadratic is touching the x-axis. So to check our answer, super duper easy, let's get out our calculators, and you can do this on your test. You can, in approximately 15 seconds, you can see if your answers are right or wrong. So go to your y equals. Now, what did we learn last class? In order to type it in your calculator, it has to be equal to what? 0. Now, we already did that, so you just need to grab, oops, I don't want purple. We just need to type this when it's equal to 0 in our calculator. So type in 2x squared plus x minus 3. And where it equals 0 are the x-intercepts. What were the two answers that we got? 1, does it look like it crosses the x-axis at 1?
Yeah.
Yeah, and then negative 3/2 is negative 1.5. Does that look like it's crossing the x-axis at negative 1.5? Yeah, so we did good. You done good.
Do good.
Okay, the next one. We're going to do one more together, and then I'm going to have you do a few on your own. So, example 6. First step is what? Set it equal to 0. So I need to subtract this 12 over to the left side. So that's going to give me x cubed plus 3x squared minus 4x minus 12 equals 0. So it's been a while, but how do we factor something with 4 terms?
Grouping.
Yeah, by grouping. Okay, so this is a good review. This is a good spiral review as well. We're doing a lot of first semester stuff today. So the way we do grouping is we divide it in half, and we focus on the first 2 terms. So I'm going to ask some people here, GCF. Cole, what is the GCF of x cubed plus 3x squared? What could I divide out of both of those terms? What do they have in common? X squared. Good. They both have an x squared. So if I factor that out front, how many x's are left from the x cubed term? 1x plus, and I took both of the x, or the x squared away, so the only thing left there is a 3. So can you see how if you distributed this back through, you'd have x cubed plus 3x squared? So we did that right. Okay. Now we focus on the second half, minus 4x minus 12. What is the GCF of negative 4x minus 12?
Negative 4.
Good. They're both negative, and they both divide by 4. What happens when you factor out a negative? They're both going to become positive. So that becomes x plus 3. Because negative 12 divided the negative 4 out front is positive 3. Then that's good, because remember in grouping, we want these to match. So what happens next is the x plus 3's get factored out front. So there's an x plus 3 in front. And if I take those away, if I factor that out front, what's left in the middle? X squared minus 4. That's your other parenthesis. Now that completes grouping. That is, we just did grouping. But sometimes, even after you group, one of the factors, or sometimes both of them, can break apart again. So, which one of these can break apart again? The one that's squared, obviously, so the 3's fine. But how does x squared minus 4 factor apart?
X plus 2, x minus 2.
Yeah, that's a difference of squares. So one's plus, one's minus, x plus 2, x minus 2. Some of you might still have your factoring flowchart. Remember that? It has all the formulas on it, and it kind of tells you how to factor. That might be good to use. So once all the x's are broken apart, we call that factoring. We just set each factor equal to 0. This is the easy part. So if the factor is plus 3, what's my answer?
Negative 3.
Negative 3. It's going to be the opposite, right? All of these are easy. There's nothing. So this one's going to be what?
Negative 2.
Negative 2. And positive 2. So how many times did this polynomial cross the x-axis? 3 real times.
How do you find out non-real?
Huh?
How do you find out non-real?
If it factors into something that doesn't factor any further. So for example, earlier on that little spiral quiz, we had this. How does this factor? Do you remember? X squared plus 4.
X plus
minus
2i.
2i.
Oh, yeah,
I, it's the I one, right? So x plus 2i, x minus 2i. So if you ever have factors that are imaginary, obviously that doesn't give us any real x-intercepts. That's a good question. Now what I want you to do, every single person in here, I want you to get out your calculator and I want you to check those 3 answers. So go back to where the polynomial is equal to 0, which is right here, and graph in your calculator to see if those are the correct 3 answers. Takes you like literally less than 15 seconds to do, and on the test, you can guarantee if you did it right or not. If you don't get it right, then obviously you factored wrong somewhere, and you can go back and check that real quick. So here is the correct work and answers for number 7, A times C. The factors of 6 add up to 5 are 2 and 3. Don't forget to do bottoms up, divide by 3, divide by 3. If you set 3x plus 2 equal to 0, plus 2, subtract 2 over, divide by 3, that gives you negative 2/3. And then if you set x plus 1 equal to 0, you'd get negative 1. Okay, go ahead and give 8 and 9 a try. If you're watching the video, you can pause for a second. I forgot to record here. So here I factored by grouping. I set that one equal to 0, I got 2. So now, if this doesn't factor any further, you still have to set it equal to 0. So this is like the front page, right? This is what we did last class. So how do I solve this for x? Add 1 over. And then I would not square root. You can't square root until the x squared is by itself. So get the x by itself. We'll divide both sides by 2. So we get x squared equals 1/2. Square root it. What do you have to remember always when square rooting? Plus or minus the square root of 1/2. Now that's an ugly decimal. You can just leave it as that. Now that is like a level 3 answer. If you circle this on the test, I'd be happy. But that's not advanced. I'll tell you why. We're going to go on a big spiral here. So see if you can follow me. Everyone stop what you're doing and see if you can follow what I'm about to write. The square root of 1/2 is the square root of 1 over the square root of 2. We good with that so far?
Yeah.
The square root of a fraction is the square root of the top over the bottom. Now, what is the square root of 1? This is 1. No, the square root of 1 is 1, right? 1 times 1 is 1. But the square root of 2 is irrational. Is it good to build a house on gravel? No, this is a never-ending decimal. You don't want the foundation of the fraction to be a never-ending decimal. So what we did last semester is we rationalized the denominator. So what we do to get rid of the square root of 2 is you multiply it by itself.
Like squaring.
Grace is like ruffling up her nose.
And you put on top too.
But if you multiply the bottom of the fraction, you also have to multiply the top of the fraction. Now this really doesn't end up being that bad because 1 times the square root of 2 is just the square root of 2 on top. Over, what's the square root of 2 times the square root of 2? If you didn't know, you could throw it in your calculator.
2.
It's just 2.
Yeah.
Remember, the square root of 2 times the square root of 2 is the square root of 4. But what's the square root of 4? 2.
Wow, look at that.
Don't forget your plus or minus.
So that would be
That is really, you should be able to do that. We did it last semester as a little reminder.
I'm not doing it.
I wouldn't be upset with this answer, but on the EOC, if this was a multiple choice, you would have to understand how to get there. You could put them both in the calculator and see what decimal matches, but 9 should be easy cheesy lemon squeezy because these are both perfect squares. So how does a difference of squares factor?
2x.
2x plus 3, 2x minus 3. So 1's plus, 1's minus. 2 times 2 is 4, 3 times 3 is 9. Now if you set these equal to 0, what do you get? Subtract 3 over, divide by 2.
3 over 2
is negative 3/2. Add 3 over, divide by 2 is
3
positive 3/2.
Oh,
That was a pretty easy one. Now, last thing for today. Hold on. Could you have done the front side with this?
Yeah.
Could we have done what we did on the front side of the notes with this problem?
Yeah.
Is there an X in the way of me solving using SADMAP? No, let's do it real quick. It's easy. So, watch this. If I add 9 over, we get positive 9. What would I do next on the front side of the notes? Divide by 4. How do you get rid of an X squared? Square root. What do you have to remember when you square root? Plus or minus. What's the square root of 9?
3.
What's the square root of 4?
2. Oh my
Whoa.
Exact same thing. They both work. So, if there's no X, you could do it either way. You can factor and set them equal to 0, or you can do SADMAP and do square root of plus or minus.
That's when it's, doesn't like,